Hey everyone, and welcome. Today we're diving into this incredible hidden battle that's happening all around us in the natural world. It's all about how temperature, just getting a little warmer or a little colder, can be the ultimate weapon or the biggest weakness in the fight against disease. So let's start with a question we've all asked ourselves. Why is it that as soon as the weather turns cold, it feels like everyone starts getting the sniffles? Is it really just because we're all cooped up indoors sharing germs? Or is there something deeper, something biological going on? Well, the answer is fascinating, and it's exactly what we're going to unpack today.
All right, to really get to the bottom of this, we first need to meet our cast of characters. In the animal kingdom, there are two fundamentally different strategies for dealing with body heat.
First up, you've got the endotherms. Now that's us, right? Mammals, birds. Think of us as walking, talking internal furnaces. We're constantly burning energy to keep our insides at a nice, stable, warm temperature, no matter what it's like outside. It's a huge advantage, for sure, but man, it costs a ton of energy.
And then on the flip side, you have the poikilotherms, what we usually call cold-blooded animals, like fish, reptiles, and amphibians. They don't have that internal furnace, so they've become absolute masters of using their environment, cleverly moving from a sunny spot to a shady one just to find that perfect temperature.
And this is where you really see the trade-off, right? It's all laid out here. Endotherms are burning all this fuel for the freedom to stay active even when it's chilly. Poikilotherms, on the other hand, save a ton of that energy, but their whole day is kind of dictated by the weather report. It's a classic evolutionary choice. Do you pay for your own heating, or do you get a free ride from the sun?
But, nature just loves to throw a curveball. The line between warm and cold-blooded, it gets blurry. Take a great white shark or a big tuna. Technically cold-blooded, right? But they figured out this incredible trick where they can heat up specific muscles, like the ones they use for swimming. This regional endothermy gives them a massive power-up, turning them into absolute super predators in the cold ocean.
All right, so we've met the players. Now, let's get back to the main event. How in the world does temperature mess with our body's ability to fight off germs?
Your immune system basically has two main branches. First up is your innate immunity. These are your first responders. Think of them like the bouncers at a club. They're fast, they're tough, and they don't ask a lot of questions. If something looks like it doesn't belong, it gets bounced. End of story. Then you've got the other team, the adaptive immune system. Now these guys are the special forces, the detectives. They take their time. They're gathering intel, building a detailed case file on the specific bad guy. And here's the kicker. They remember. They keep that file, so if that same invader ever shows up again, they can shut it down instantly.
And this is the absolute crux of it all. According to the research, cold temperatures don't really bother the bouncers. That innate response keeps chugging along just fine. But the cold absolutely cripples the detectives. That whole slow, careful process of building a case file and calling in the special forces, it just grinds to a halt when things get chilly.
And there it is. That's the aha moment that answers our big question from the beginning. That common cold virus, the rhinovirus, loves the cooler air inside your nose. At that slightly lower temperature, your fancy adaptive immune system, the detectives, is basically sluggish and slow to respond. And that gives the virus the perfect head start it needs to set up shop and make you miserable before your body's main defenses even know what's happening.
And if you want to see this in action, really see it, look at these walleye fish. It's wild. In the cold water of fall and winter, their adaptive immunity is so suppressed that they get these viral skin tumors. But then, like magic, as the water warms up in the spring, their immune system wakes up, goes on the attack, and the tumors just disappear.
So it sounds like the cold gives pathogens the upper hand, right? Well, not so fast. Animals can flip the script and use heat as a powerful weapon of their own.
For us warm-blooded folks, though, this weapon is expensive. Getting a fever isn't free. For every single degree Celsius your body heats up, your metabolism has to work about 10% harder. Think about that. Your body is willing to pay that high-energy price, which tells you just how critical this defense is.
So how does it actually work? Well, when an invader gets in, your immune cells sound the alarm. They send a message straight to your brain's thermostat, the hypothalamus, and tell it to crank up the heat. A fever isn't you being sick, it's your body actively fighting back. That higher temperature puts your adaptive immune cells into overdrive, making them way faster and deadlier. And what's so cool is that cold-blooded animals do the exact same thing. They just do it differently. It's called behavioral fever. A sick lizard just knows it needs to get warm, so it'll go find a sunny rock and just bake itself. An infected fish will swim to the warmest part of the pond. They're manually creating the same fever that our bodies create automatically.
Okay, so this whole connection between temperature and immunity, it's more than just a cool biology lesson. It has huge, and I mean huge, implications for our planet, especially right now.
As the world warms up, it throws this whole delicate dance into chaos. I mean, think about it. Animals built for the cold, like reindeer, are now dealing with heat stress. Parasites, like ticks, which used to be killed off by harsh winters, are now surviving and spreading into new areas. Fish farms are on a knife's edge, where a tiny change in water temperature can lead to a massive disease outbreak. And it even affects animals like bats, whose suppressed immune systems during hibernation might change how they carry and spread viruses.
So you have this ancient arms race, right, between an animal and its pathogens, a fight that has been shaped by the environment for millions of years. But now, we are changing the environment. We are turning up the thermostat on the entire planet, and we're doing it fast. And that leaves us with one really big question. In this new, warmer world, who has the advantage?